Dear students, welcome to Physics World. Today we shall discuss about certain important terms which we often come across in matter. So first thing which we are going to discuss is the intermolecular force of attraction. The meaning of intermolecular force of attraction is the force of attraction between the molecules. Any kind of molecules of the same kind or of different kinds is called the intermolecular force of attraction. Now there are two kinds of intermolecular force of attraction. One is called the cohesive force. The force of attraction between the like molecules are called cohesive force. For example, suppose we talk about the force of attraction between the water molecules, or say the force of attraction between the air molecules. So in that case, because the force of attraction is between the like molecules, therefore it is a cohesive force. So over here the keyword is like molecules. I just want to remind you children that when we are talking about the keywords means those words which we are going to stress on while writing any particular answer. So now coming back to another form of intermolecular force of attraction, that's known as the adhesive force. The force of attraction between unlike molecules. So the key word over here is the unlike molecules. So the unlike molecules, the force of attraction between them is known as the adhesive force. For example, the force of attraction between glass molecules and water molecules. You must have noted, dear students, that if you take a glass of water, we take a glass of water, and then if you drink that glass of water, and after you have finished drinking the glass of water, you will see that there are some droplets of water molecules sticking to the glass tumbler. Why this is so? This is because of the adhesive force between the water molecules as well as the glass molecules. Now dear students, we shall talk about another term, that's the surface tension. And sometimes this is a very confusion, it creates confusion among the students. So let us see what we understand by surface tension. When the outer surface of the liquids behave like a stretched string, this property is called the surface tension. So now let us understand why the outer surface of liquids behave like a stretched string. The outer surface molecules, suppose over here we are taking some liquid, and we have shown over here the liquid molecules. Now the outer surface molecules experience two kinds of forces. One, a downward force due to the pull of the downward molecules. Now let us see the molecules over here. Suppose we take this molecule, say A over here. This molecule is being because of the intermolecular force of attraction or the cohesive forces between the like molecules, this molecule is being pulled on the left by another molecule this side, and it is also pulling it back definitely. But let us see, only observe this A molecule. This is being pulled towards the left, towards the right, down, sideways, everywhere. So as a result, this surface molecule is being pulled downwards, sideways, everywhere by the neighboring molecules. This is only a two-dimensional structure, children. And now if we see the molecules in a three-dimensional manner, because it is always like this, a three-dimensional structure. Okay, so then this molecule will also be pulled by the surface layer of the other neighboring surface layer molecule. So obviously there is a downward force due to the pull of the downward molecules and a pull of the surface due to the neighboring surface molecules. So as a result, the outer surface of the liquid behaves like a stretched string. and this property is called the surface tension. One example of surface tension is that the tiny droplets of water or rain droplets are spherical in shape. Next, another very important term we come across while studying matter is viscosity. It is the resistance of a liquid to flow. For example, it is due to the friction. Suppose you take honey and you take water. You stir both of them and just leave it like that. You will see that honey will come to rest faster than water. This shows that honey is more viscous than water. Next term is free surface. The surface of matter that is in contact with the air is known as the free surface. So we can understand that solids can have any number of free surface, or it can have infinite number of free surface. Liquids have fixed volume but no fixed shape, and therefore liquids have only one free surface. You take in a glass of glass, take some water. This is the free surface, which on one side is in contact with the water molecules, other side it is in contact with the air molecules. Gases, they have no free surface. Now there are some important questions which are frequently asked. One question is, a piece of chalk breaks easily, whereas an iron piece does not. Why? So, dear students, whenever you are explaining something, always explain on the basis of intermolecular force of attraction and intermolecular spacing. So, the first thing which you are going to say is over here that the intermolecular force of attraction, or the cohesive force between the chalk molecules, is much lesser compared to the iron molecules. Hence, and the intermolecular spacing, over here you have to talk about intermolecular spacing also, and the intermolecular spacing is also larger. Intermolecular spacing larger. Hence, a piece of chalk breaks easily, whereas a iron piece does not. Next question is, why do solids not have or exhibit the property of viscosity? We know what is viscosity. So now the question is, the solids do not exhibit the property of viscosity. Why is this so? The cohesive force of the solids are very strong, and the intermolecular spacing is very less. As I told you, dear students, always explain anything on the basis of intermolecular force of attraction and intermolecular spacing, which you have learned. So the cohesive force or the intermolecular force of attraction of the solids are very strong, and the intermolecular spacing is very less. Thus they do not flow, and viscosity does not exist. The question of viscosity does not arise at all. Another frequently asked question is, why are raindrops spherical in shape? Now, this is due to the cohesive nature of the water molecules. The surface molecules of the raindrops prefer to bond with this. Suppose this is the raindrop. Okay. Now, there are certain water molecules over here. Now, it prefers to bond with the neighboring water molecules rather than bond with the air molecules over here, and therefore it forms a spherical drop. Dear students, I felt that these are the main areas where the children find difficulty in understanding matter. Other things are definitely given in the book. We shall be coming up with some more questions in the upcoming videos. So please like, comment, share and subscribe. Your subscription matters a lot to me. Thank you.